In this presentation, we will find out the time complexity of inserting the data at certain position in case of array. So let's get started. Here I am considering this array which consists of 10 elements, for example. Now we want to insert a new element at position 5. Let us suppose that we want to insert a new element at position 5. That means at this particular position, we want to insert a new element. I am considering that this is position 1, position 2, position 3, position 4, and this is position 5. At this place, we want to insert a new element. Let us suppose that we want to insert this element 78. For this purpose, we need to create a new array of size greater than the original array. This is the first step required because we want to insert this new element at this position. For this purpose, of course, we need to create an empty slot here and we have to shift our elements towards right. Right now, I'm considering that this array has 10 elements and the size of this array is also 10. That means we can add only 10 elements in this array. That is why there is no empty slot available over here. That is why I can't make an empty slot in this new array. That is why there is a requirement of creating a new array of size 1 greater than the original array. So here you can see I have created a new array ARR2 which is having the size 1 greater than the original array. After this, we can copy everything up to position 4 and paste it in the new array. That means starting from this point and going up to this point. Okay. We will copy everything and we will paste it in the ARR2. We will copy everything from this point to this point and paste it in ARR2 as you can see over here. After this, we will insert the new element at position 5, that is at this position. We will insert our element and then we will copy the rest of the elements from the previous array to the new array. And this is how it looks like. These are the simple steps we should follow in order to add an element at certain position. Now here is a program which helps us in doing the same thing. Here I'm supposing that this is the array which we are available with and here these are the elements of this array according to the example, right? I need to create these two variables, pos and data. Pos indicates the position where we want to insert our element and data indicates the data, that is the actual data we want to insert, right? And obviously this size variable is required to find out the size of this array. Obviously it gives us the size 10 because here we have 10 elements in the array. And obviously after this we need to create a new array of size 1 greater than the previous array, that is the original array ARR. So here the size must be size plus 1. That is why this size variable is required, right? We need to find out the size of this array. Size is 10, so the size of the new array will be 11. So an extra space is created for the element that we want to insert. So this piece of code is helping us to create an ARR array, ARR2 array, pos, data and size. After this we will call add@pos function where we pass ARR, ARR2, size, data and pos. And here is the function add@pos. This function receives those parameters, so we can see we have ARR, ARR2, pos, data and variable n in our add@pos function. Here this n indicates the size of this ARR array. You can see over here, this n will receive the size of the ARR array. Now here in this function, we have this index variable which will store the index of the particular position where we want to add the data. We know that pos variable gives the position where we want to add the data, but index will give the actual index of the array where we can put our data. Here in our example, we are considering position 5. That is why index will contain the value 4. Because at this particular index, we want to add our data. That is why index variable is required. After this, we will use this for loop which runs from 0 to index minus 1. That means we want to copy everything from index 0 to one position less than the position where we want to insert our data. So here in this case, you know that index contains this value 4. So this will get replaced by 3. So it runs from 0 to 3. Okay, that means from 0th index to 3rd index. We will copy everything and paste it in the ARR2 as you can see over here. After this, we will put our data in the desired position. So 78 will get added in index number 4. And then after that, this step is required to add the rest of the elements in the new array. Here you can see that I'm using these two variables I and j. Here I is used in ARR2 and j is used in ARR. You can see that I is initialized with index plus 1 and j is initialized with index. Here we are checking these two conditions, I less than n plus 1 and j less than n. And I'm incrementing both I as well as j. So here the I is initialized by 5, j is initialized by 4, n plus 1 is replaced by 11 and n is replaced by 10. And I and j will get incremented by 1 each and every time. Now why? I'm initializing I by 5, j by 4, and why I is less than 11 and j is less than 10. You can see that here we want to copy everything from index number 4 to index number 9 and paste it to the new array from index number 5 to index number 10. That is why you can see that I is initialized with 5 and it goes up to index number 10. And j is initialized by 4 and it goes up to index number 9. You can see that j is initialized by 4 and it goes up to index number 9, and I is initialized by 5 and it goes up to index number 10. Here you can see I is used in ARR2 and j is used in ARR. With the help of this for loop, we would be able to copy the rest of the elements from ARR to ARR2. So all the elements from this point to this point will get copied in ARR2. After this function evaluation, we get back to the main function, and then we'll use this for loop to print all the elements of ARR2. Of course, the size must be size plus 1 here. So the output of this program is 2, 34, 21, 6, 78. This new element is added 7, 8, 90, 67, 23 and 39. And of course, the time complexity of this particular function is big O of n. The add at post function takes this much amount of time, as we have to copy all the elements of the original array to the new array no matter what, right? And obviously there is one more element added, so the time complexity will be big O of n. That depends on the size of the original array, right? So here n represents the size of the original array, and that is why the time complexity is big O of n. As you can see that here this is n, right? That is why I have written n over here. N represents the size of the original array. No matter what, you're copying all the elements of the original array to the new array. That is why the time complexity is big O of n. There are some points I want you to remember. First, we can't return an array from a function because an array created in the function is local to that function. This is the reason why ARR2 has been passed as a parameter to a function, and passing ARR2, that is the name of the array, is equivalent to passing the address of the first block of ARR2. So the changes made in the called function will be reflected in the caller function. That is why it is required. That is why we have created ARR2 in the main function and we are passing it as a parameter to a function so that the changes will get reflected in the main function. We can't return an array from a function. That is why it is important to create ARR2 in our main function itself. We know that passing the name of the array is equivalent to passing the address of the first block of array. So the changes will get reflected in the main function. And that is why ARR2 is created in the main function. Okay, so these are certain points you should remember. Okay friends, this is it for now. Thank you for watching this presentation.